It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farmers Union Nice Coffee. Hi guys, welcome to the first video in the monitoring the environment topic. I'm going to be producing 5 videos on this, which is just using the PowerPoint that I've put together. So if you haven't already downloaded this, I suggest you do that from my website as well, which is chemwithstapo.weebly.com. And the password is iced coffee. So if you haven't actually downloaded the PowerPoint, I suggest you do that. Before I get into this first topic, I just want to remind you, and the reason it's really useful to have that PowerPoint is because you'll see embedded in here these YouTube play buttons, and this gives a direct link to videos which I've done relating to specific topics. So if you want more help on the topic than what I'm just presenting in the slides here, which will be a very brief overview, I suggest you download the PowerPoint and you click on this button to take you directly to that link. So the first thing we're going to be looking at in this topic is all about global warming and climate change. So in particular, we're going to be looking at carbon dioxide, and carbon dioxide is a very important molecule. All right, it's a gas at room temperature because it's a non-polar molecule which is held together by weak secondary bonds. Okay, now if you need more information, help about drawing structures and making sure you know the shapes and everything of molecules, there is a YouTube link down here that you can click on, and that'll take you to that video which talks all about drawing the structures of molecules and making sure you've got an understanding in your head of what makes them polar or non-polar. And then there's also a video as well about hydrogen bonding or dispersion bonding and secondary bonds you might want to look at. Now, carbon dioxide is a non-metal oxide, which is important because if you know your trends in the periodic table, what that means is that it's going to be an acidic oxide. When we dissolve this in water, we actually get an acid formed, which is quite important. So if we're talking about carbon dioxide and the greenhouse effect, first thing you need to understand is the greenhouse effect is natural. Okay, you have this short wavelength radiation from the sun passing through the atmosphere and absorbed by plants. Now we've got a bit of an information there, but what I'm actually going to do here is on this slide, I'm actually going to show you that. All right, so I'm going to try and draw on here. So we've got some short wavelength radiation that comes down from the sun. Okay, now this short wavelength radiation is also known as UV radiation. Okay, and because it's short wavelength radiation, it doesn't get absorbed by greenhouse gases in the atmosphere, such as carbon dioxide. What happens is it gets absorbed at the surface of the earth. So by plants, animals, buildings, everything, it absorbs the heat. So when they're out in the sun, things get hot. Okay. What we then do is, humans are a good example of this, we re-radiate it as long wavelength radiation. Okay, so this is long wavelength. And if you don't know the symbol for wavelength, it's just that lambda there. Okay, long wavelength radiation. All right, so re-radiated from the surface of the earth. And when it gets to this layer of greenhouse gases over here, such as carbon dioxide, other ones are methane, and another one is water vapor, they're the natural ones. Some of it gets trapped by the greenhouse gases and some of it escapes into space. Okay, so we've got some of it escaping into space and the rest of it is trapped and reflected back towards the earth. Now that's the natural greenhouse effect. It's a good thing. What it does is it means that the earth maintains a mean global temperature of around about 17 degrees Celsius, which is very important because that allows us to maintain life on earth. The problem is that we have the enhanced greenhouse effect. Now, the enhanced greenhouse effect is where humans have increased the concentration of carbon dioxide, methane, water vapor in the atmosphere, okay, through things like deforestation, which prevents trees from removing carbon dioxide. When we also cut down trees, we also are releasing carbon dioxide normally. Trees are what we call a carbon sink, because we normally use those as a fuel source. So combustion engines release carbon dioxide through combustion of petrols. Rice paddies are a really good source of methane. There's a lot of what's called anaerobic decomposition that occurs there within rice paddies, and that releases methane gas. And then increased mining also releases trapped pockets of methane within the earth. Okay, so all of those increase the concentration of the gases in the atmosphere, and that leads to the amount of re-radiated heat that is given off by the earth to be increased as the amount that's absorbed. And when the amount that is absorbed, and this is the key bit in red here, when the amount of heat that is absorbed is greater than the amount of heat released to space, we get an increased warming of the earth. And this could lead to an increase in mean global temperature, and it is actually in fact leading to an increase in mean global temperature. Now, even if that's only half a degree, 1 degree, 2 degree, that has very, very severe consequences. And some of these consequences are things like a rise in the global mean temperature, as you said, going up from say 17 to 17.5 or 18 degrees, which doesn't seem by much, but you've got to remember that's the average temperature. So some places will experience a much more severe temperature change than that. That will result in climate change. All right, so even a couple of degrees change will change the climate of Adelaide, for example, in South Australia, where I am, quite significantly. Could make us more tropical, make us a bit more like Queensland, for example, which may not sound like a bad thing, but in actual fact, what that's going to do is have severe impacts upon the flora and fauna here in South Australia because they're not used to that kind of climate, and it's going to have an impact upon our agriculture here. We produce a lot of wheat and wine in South Australia, and we're not going to be able to do that in the warmer temperature that we've got. We will get enhanced weed growth. Weeds grow very quickly in warmer environments. So if you've got warmer, moisture environments, which could happen through increased global temperature, that's going to obviously impact your crop development as well. And the other one is increased sea levels. So this is a really good example where you've got cities like this, which are right here near the ocean. What's going to happen is that increased temperature will cause icebergs to melt. Obviously, ice is less dense than water. So as it melts, it creates, it takes up a greater volume than if it was the ice itself. Okay, and it's not really so much the icebergs itself, but it's more the landlocked ice. So in Antarctica, for example, in particular, there's a lot of landlocked ice. That means the ice that's on the land, as that melts and goes into the oceans, that's going to severely increase the water levels. And you could get places like this, right, could actually be completely underwater with increased sea levels. So it's quite a severe problem if it continues. In order to reduce the enhanced greenhouse effect, we can limit the amount of gases going into the atmosphere a number of ways. So we can place limits on logging, all right, make it sustainable logging, so we're planting more trees. We conserve energy, and renewable energy sources is important. So we've got some examples here of wind energy, which is very prevalent here in South Australia. We have the highest proportion of renewable energy anywhere in Australia. Okay, we've got hydro energy here, so things like using hydroelectric dams. Okay, solar energy, and then we've also got some wind energy, which is a bit hard to see in that one, but that's wind energy as well, which is again a little bit different from the wind turbines. Controversial one is about limiting population growth. Limiting population growth, obviously, there's a lot of moral ethics that come into that. And so that's one which is a little bit more controversial about whether you can impinge on people's rights to have a certain number of children. Now, carbon dioxide, as I mentioned earlier, is a non-metal oxide, which makes it acidic. Now, what that means is that when it dissolves in water, here we get this reaction, we form carbonic acid. Now, it's only a weak acid, and what we mean by weak acid is that it only partially ionizes in water to produce hydronium ions. So when you get this so it's carbonic acid, dissolving in water, you get carbonate ions and you get hydronium ions. Okay. Now, sometimes for acid, you'll see hydronium ions, or you'll also see H+. Those two basically mean the same things. And so the concentration of that determines how strong, how acidic it is. Because it's only a weak acid, there's not a huge amount of H+, but as we increase the carbon dioxide concentration in the atmosphere, we release more and more of this hydronium ion into the water. As we increase more of the concentration of the H+, the pH of the water decreases. Okay, so if you don't know how to calculate the pH, okay, this is the equation that you use up here. Okay, pH equals negative log concentration of H+. So as the concentration of your H+ increases, okay, your pH is going to decrease. Okay, currently carbonic acid sits at around 5.6, so it's in here. It's not overly acidic. All right, that's the 5.6 is what we call acid rain. Okay. And as we increase the H+ concentration, that pH will start to decrease as we increase that H+. All right. So the more carbon dioxide we put in the air, the more that gets absorbed by the oceans. Okay, and the lower the pH will become as well. Now, the effect that has is that acidic oceans can harm marine organisms that use calcium carbonate or limestone to build their shells or skeleton. So some examples: clams, oysters, scallops, urchins, crabs, lobsters, prawns, all very, very delicious. Not so sure about urchins, haven't really tried them, but the other ones are really, really nice, and I, for one, don't want those to disappear. The calcium carbonate shell they have in their exoskeleton is very vulnerable to dissolution. So what that means is they can be dissolved very easily. So here's the equation here. The calcium carbonate in their shells reacts with the acid in the water, and it forms calcium ions. Okay, and their shell, it produces CO2, which obviously will dissolve in the water and further lower the pH. So it's a kind of a vicious cycle. All right, so if they have reduced or weakened shells, a lot of them use their shells over here to actually survive. So it's really important that that's not weak. All right, that's the end of the first topic. As always, if you've got any questions, just ask. But I suggest you make sure you have a look at the PowerPoint and before you go on to the next one. Thanks, guys.